Okay, so yesterday we were looking at equivalent fractions, and if you remember, we'd have a fraction in the middle, like 1/3, and then all the way around the outside we had lots of other fractions that had bigger numerators and bigger denominators that were equivalent or had the same value as that one in the middle. Now what we're going to look at today is kind of a backwards process. We're going to start with bigger fractions, okay, with bigger numerators and bigger denominators, and then what we've got to do is simplify them down so that they cannot go any lower. So there are a couple of words that you might see this called. It's called simplifying anyway. So one of the words that you might see is simplify, okay? So it might say simplify these fractions. Another one you might hear is lowest terms. Give this fraction in lowest terms. And what that means is simplify it. Also, simplest form. And you don't really hear it called this very much these days, but when I was at school we called it this all the time, and it's cancelling. So you've got to cancel the fraction. And that means also put it in its lowest terms. So when we are given a fraction, say for instance we're given something like 25/30. What we have to do, remember yesterday we were looking at making equivalent fractions, and we had to treat the numerator and the denominator exactly the same, didn't we? Well, that also pertains for this. You have to treat the numerator and the denominator exactly the same. So what we've got to look for is a number that will divide into 25 and will also divide into 30. And preferably the biggest number that does that, okay? Can anyone think what that's called? The biggest number that divides into two.
Highest common factor.
Perfect, the highest common factor. Well done, Emma. The highest common factor. So the highest common factor is the biggest number that goes into both. Because obviously, 1 goes into both of those, doesn't it? But if we divided 25 by 1 and divided 30 by 1, it would still be 25/30, so it doesn't really help us. So what is the HCF for that one?
5.
Well done, 5. So our HCF, or our highest common factor, is 5. And so what we do then is we divide the numerator by 5. So 25 divided by 5 gives us 5. And 30, we have to do the same to, divide it by 5 is 6. So 25/30 in its simplest form, or lowest terms, or simplified or cancelled, is 5/6. Okay, I'm just going to rub out highest common factor because we've talked about that. So, let's have a look at something like, say, 66/100. Now, this one, I don't know the factors of 66 particularly. I could work out the factors of 100, but I don't know them. But what have both those numbers got in common?
They're both common numbers.
They're both big numbers, that's right. But what have they got in common, Molly?
They're both common. They're both even numbers.
Good girl. They're both even numbers. So that means they are divisible by 2. That's right. So if you come to a fraction, a big one like this, and you don't know the factors, and they're both even, always divide it by 2 first of all, and then you can keep going. So, what is 66 divided by 2?
33.
33, and 50 divided by, 100 divided by 2?
50.
50, okay. Now, we look at that, and we have to see, are there any more common factors between 33 and 50? Can we cancel it any further? And in this case, we can't. So what we'll do, I'll give you another example. Say 48/100. Okay. Now, this one does have a higher common factor than 2, But if you don't know what that is, it doesn't matter, because you don't have to simplify in one step. You can simplify in 2 or 3 or 4 even. So, as we said, they're both even, so they'll both divide by 2. So what would that cancel to, Talon?
Just like the first step, like half.
Yeah, just the first step, yeah.
24 over 50.
24 over 50, that's right, 24 over 50. Now, do 24 and 50 have any common factors?
12 and 25.
Well done, that's right. So that cancels to 12 over 25 because they both also divide by 2. So we're looking all the time to find the highest common factor, because then you can do it in one step. But if you don't know what the highest common factor is, you can always do a lower one and do it in a few steps. So let's have a look at, say, 42 over 63. Can anyone think of a common factor, the highest common factor of 42 and 63? Marshall?
6.
Does 6 go into 63? It doesn't, does it? It would be 66 or 60, wouldn't it? But you're on the right track.
3.
3 goes into them both. Well done. Okay. So, you could, if you wanted to, divide them both by 3. How many 3s are there in 42? It's 14. And how many 3s are there in 63? There are 21. So, they do divide by 3, but 3 was obviously not the highest common factor. So what can we do to the 14 and the 21?
Divide it by 7.
Divide it by 7, that's right. So, that one will be 2, and that one will be 3. So, can anyone work out what the actual highest common factor was?
7.
What wasn't actually, no, Lachlan.
Oh, because it's 7.
No, because if we divided it by 3 there, and divided it by 7 there,
9.
no, good try. Well done, 21. Because 3 times 7 is 21. So if we divide by 7, and then divide by 3, that would be the same as multiplying by 3 and multiplying by 7, or multiplying by 21. You with me?
Yeah.
Because there are 2 21s in 42, and there are 3 21s in 63. But I don't know the 21 times table, so it didn't matter that we did it in 2 steps. Okay? You're looking a bit, you look like you don't believe me. Okay. So let's have a go at this one then. Okay. So we're going to have a big number, and we'll see if we can do it. We're going to have 500 over 1,000. Now, you probably could do this in one step if you wanted to. But if one of the reason I've chosen this is because I want to show you what happens when you've got zeros above and below the vinculum. So we've got 2 zeros there and 3 zeros there. What can I do when I've got zeros above and below?
Divide by 10.
I can get rid of one of them, can't I? I can get rid of that one, cancel it, because if I divide the top by 10, I can also divide the bottom by 10, so that's how I've done it. What else can I do though? Now, look at that, 50 over 100. Jack?
You can divide it by 100.
I could, from the beginning, I could have divided it by 100, yes. So I'm going to divide it by another 10. So I'm left now with 5 over 10. And what can I do then, Talon?
It's 1/2.
It's a half, yeah, because there's 1 5 in 5 and 2 5s in 10. Okay, and you might have realised that because 500 is half of 1,000. But I wanted to show you how you can do it in various stages. So something like this, for instance, 600 over 1,250. What could I do then? Yeah, cut off one of the zeros. So now we're left with 60 over 125. What can I do then? What do they both divide by? They do, yes. So there are 12 5s in 60. How many 5s are there in 125 though? 25, that's right. So 12 over 25. Okay?